storybook we chose to focus on was The Lorax. The Lorax is a children's book written by Dr. Seuss and published in 1971. This book stresses the importance of protecting the environment and only taking what you need. Although it was published many years ago, it remains to be relevant today.
We have decided that a suitable target year level for this book and system would be Year 3 students. This is due to the ideas portrayed by the Lorax's storyline relating to sustainably designing and constructing products, which strongly ties into the Year 3 Design and Technologies Australian curriculum. Furthermore, it ties into the Knowledge and Understanding strand, and more specifically the Technologies and Society substrand of examining design and technologies, occupations and factors including sustainability that impacts on the design of products, services and environments to meet community needs. Both the book's storyline itself and the way the systems have been designed also importantly emphasise the cross-curriculum priority of sustainability, which can be carried through to other subjects such as English. It can be used to cover the substrand of identify how images extend the meaning of a text. This book can also be integrated into science and humanities.
Two systems have been included to bring the scene to life. A pneumatic system consisting of two connected syringes allows for the Lorax to rise out of the tree trunk whilst also triggering an electrical system which turns on a light globe. The pneumatic system works by pressing the first syringe, which forces compressed air into the second syringe, extending the plunger through the tree trunk. The process is then reversed by then extending the first plunger, which forces the second plunger to drop, causing the Lorax to disappear. When the second syringe is fully extended, the electrical circuit is activated. This happens when alfoil located on the second syringe comes into contact with the picture frame hook located on the inside of the tree trunk, which completes the circuit and turns the light on. The result of the systems is most appealing in a dark area. The only identifiable risk that we found while creating this model is the loose wires involved in the electrical circuit. To minimise risk to students, all water needs to be isolated from and around the model. Additionally, it should be placed on a stable table so it can't be knocked over. Safe use of syringes should also be demonstrated by the teacher.
We looked at different picture books to decide which one would be the most suitable for this project. We focused on finding something that could easily be brought to life and incorporate two systems. We decided the Lorax would be very appropriate due to the ideas expressed in the story and the relevance to the Australian curriculum. After reading the book, we then decided to sketch some ideas of what the finished product could look like and decide on what page we would create. The scene that we decided on involves the Lorax jumping out of the tree trunk, which we believe could sustainably be turned into a working model. Our focus then turned to collecting, when possible, recyclable and reusable materials. This includes a shoebox, coloured paper, paints, cardboard, alfoil and a picture frame hook.
We then started to produce the model. Firstly, we created the base, which the scene would sit on. The truffula trees were created using plasticine, pom-poms and paint. The background was then constructed using the reused cardboard and coloured paper. Next, the circuit was set up connecting the pneumatic and electrical systems. Lastly, the Lorax was attached to the syringe and the final details were applied.
Overall, we believe the model showcases the scene very well and integrates the systems effectively. However, we did come across some challenges that we needed to resolve. The main one was the integration of plasticine, which made the construction of the electrical circuit challenging and initially caused truffula trees to fall over. In order to resolve this, the thickness of the plasticine needed to be increased, allowing the circuit to firmly stick to the tree trunk. To resolve the issues we had with the truffula trees, wire was inserted to the tree trunks to make them more stable. We were able to overcome these challenges by collaborating and discussing resolutions to these problems. Through sharing the task, time was able to appropriately be spent on each part of the model, allowing the end result to be of high quality.